So, um, okay, so my name is Anthony Alaribe. I'm the co-founder of a company called Monoscope. Um, we used to be known as API Toolkit, but things happen. So the TLDR is that we believe that software issues, or actually APIs, just they talk a lot, right? API systems keep talking with each other, or our customers keep speaking with our systems through the APIs, and in that gossip that is happening, a lot of gems are hidden in there. So the whole point of Monoscope is, if we can record every single thing, record everything our customers are doing, record the logs, the database calls, everything, can we catch issues automatically? So now let's just jump in. I'm gonna try to keep today, quite light. Um, I have a small favor. I know I should have kept this to the end, but it's a QR code. We're an open source project, which means the only way people trust us is if we have some stars on GitHub. So I'm begging today is that you just scan the QR code and just give us a star. I mean, it's free to give a star. And if you give a star, you can stop. You can meet me later and I can give you some swags or something. I appreciate that. So maybe 5 seconds and then keep moving. Thank you. Okay, gotten a bunch of stars. Okay, I appreciate everyone who's giving us stars right now. So, software monitoring is solved, right? I mean, I already went to the other slide, so you know that I don't think they are. Um, but we have a lot of companies, through the years. There's Datadog Sentry, there's Grafana. So there's been a lot of companies trying to solve these problems, through so many years. So you would expect that this problem is solved. I mean, there's dashboards, beautiful dashboards. Um, I don't know, all kinds of things getting tracked in these platforms. But there's a problem that I refer to as the green dashboard paradox. And this is where you have your Grafana or whatever dashboard saying that everything looks green, everything looks good, but then your customers are probably tweeting angrily because they tried to send money and the money disappeared or something else happened, or they're pulling their hairs out because something, they clicked on the login button and they did not log in. So if our monitoring was good enough, then the dashboard should not be telling us that everything is perfect when our customers are crying, right? So maybe I'll start by just telling a little bit of a horror story. But this time, the horror story does not include JavaScript. JavaScript is always the cause of most horror stories. But I used to work for a company in Germany called Delivery Hero. And at the time, my responsibility was writing some legacy PHP, very PHP code from like 20 years ago to Go, just so it's faster. And we did the best things that you would do. We had a lot of tests. We had the same monitoring. We had automatically generated documentation, all of that good stuff. And when we deployed this, when we pushed this to production, within within a couple hours, we lost more than more than 2 million euros worth of orders, and from one single field. Actually, the field was allergy, in the JSON response, and that allergy field was missing. And this is what my notifications looked like at the time. We can make some. So it was just the grace of God that I had my job after that incident. But I mean, you can imagine just one single field, and more than $2 million just disappeared. And of course, it took a bunch of stress to debug this, right? We tried to log every single thing, log the requests that are coming in. But every time you log all that stuff, you need to deploy, you need to push it somewhere, to see, and time is going, your heart is beating, you're getting those Slack notifications. Why couldn't we catch this one single field? The reason is simply because of the paradox that we spoke about, right? All the dashboards we had said everything was good. The requests were 200. perfect latency numbers, no errors, no exception. It was just quiet. But then the revenue chart of the company was, and so this is the case for most of the apps we build, that most of the issues that happen are just invisible and disappear. There's a quote that I like to remember or I remind myself. It's by this Donald Rumsfeld. He used to be the Secretary of Defense for the US. And he says this, that there are known knowns. So that's things that we know. There are known unknowns. And that's the thing that we know that we don't know them. So we kind of know that something can happen. We don't know what exactly it is, but we can anticipate. And then there are unknown unknowns. And that's stuff that you don't even know, like anything can happen. And even for them in the military, these unknown unknowns are the most dangerous and the most scary kind of things to worry about. I think I have a quote. So, but the goal of everyone, all of us as engineers, is that we want to move as much things as possible to those unknown unknowns. But let me maybe just as to in developer speak. So the known knowns would be something like how I know that if with the way our customers are growing in my product, at some point the database is going to crash because we're going to hit the limit of connection limits or something. So we know that that's going to happen. And the good thing about such a problem, a known problem, is that we also know a solution, and we can put a solution. Maybe the solution might be to have many database read replicas, or to have a failover, so that when that database crashes, that we know it's going to happen, that there is a failover to just continue. And another example of, maybe an example of a known unknown would be, yes, we know that this thing is going to crash, this database is going to crash, but we don't know when, and we don't know how it's going to crash. But because we already anticipated it's a known unknown, we can put a solution. For example, we can have an on-call schedule. We can rotate and say, okay, at every point in time, someone is responsible for just being available, in case this happens. And then we can create monitors to alert us when that known unknown actually happens. Unfortunately, unknown unknowns could be something like the database stops returning English and starts returning everything in Latin. No one was expecting that, so there's no way to prevent it. So, the modern monitoring systems that we have are very good at known knowns, things that we can convert into a number. For example, if there is an increase in the number of 400 and 500 request status codes from your server, that's a number you can easily measure. You can create a metric on Grafana or anywhere to catch this and react to them. So our monitoring systems are good at those kind of things. Unfortunately, they're not very good for things that are more vague. And I'm going to give some examples of other issues that happen in our systems, which maybe we could call known unknowns. For example, let's say you work in a microservice architecture. You have different teams that own different services. And one day, one of the teams introduces a new status code or a new status for, let's say you are an e-commerce platform. So the person introduced pending approval. Maybe they sent you a Slack message 3 months ago that, oh, we're going to introduce pending approval, but you forgot. And now the requests are coming in with pending approval. Things are breaking, but you don't know why those things are breaking. So this is an issue that we all face. Another example of issues that we would face, and actually I wanted to show. Sorry, my slide is a bit broken, but I can't fix it now. So, another issue that is very uncommon, very common. Sorry, I can't show it. Is when the data that was expected in the field changes. So the example I was going to show here was a story that happened to a company I knew. They used to use the library for date and time. And that library was created by an American. Americans like to use their date format in as month, and day, and then year, right? And so people argued about this for a bit, and then eventually got changed to the international standard, which is day, month, and year. Very small change. Unfortunately, this was the result of that change, that a lot of the dates in people's addresses were now 1900, because you could not pass some of the dates anymore, because you were expecting month, and then all of a sudden one of the libraries that you use made a small change and the date cannot be passed anymore. So this kind of nuances happen in our systems, and how can we even catch this kind of nuance? So another incident, a very quick one, I'm not going to spend time, but imagine when you have a JSON endpoint or a JSON field, and all of a sudden it also looks different. How do you build a monitor that can catch that kind of issue so you can fix it or at least know about it and not have it just hidden? So there's a video I wanted to show. Where is it? Oh no. I don't know if you know this video. I can't hit play. Oh, sorry. I can't hit play. I don't know why. But that video is something Square holds. I like it. Because basically, all the requests that are coming in and out of our servers are the Square hole. We don't really know what's going on in there. So what the point of this talk is not talking about problems. It's about how we solve these problems. And so the solution is basically these two things. We leverage a technology called Merkle proofs or Merkle trees. I'm going to show very quickly. And then we leverage LLMs to fix and solve this. So why is it that these problems could not be solved before? The reason is that you need a bit of reasoning. You need a bit of the ability to think. So if I show you two requests, or let's say I show you 10 dates, the first 9 dates were day, month, year, and then by the 10th one, it becomes the reverse. As a human, you would already know that something is wrong. So anything or any human that can reason can easily catch these things. But now, in 2025, 2024, we now have LLMs that are able to reason and see those same patterns just like a human would. And that's why this is now possible. So what's a Merkle tree? Sorry. Strange. Okay, so maybe I'm going to use this first. I wanted to just show what's important. So the first thing is that you're already tracking all the requests in your server, and that you have the payloads, the body, the request and the response body. Now, let's say you have all of that stored somewhere, put it anywhere, put it in Postgres anywhere. What's the next step? You can't send all those, you just can't send all those requests to an LLM to say, oh, look at all of these requests and tell me if something looks strange. It would just be too much. Imagine if you're doing 1 million requests per minute. Can you send all of that? I mean, you can if you're Jeff Bezos or something, because it's expensive. But it allows us to take a bunch of data and convert that data into a very small hash that represents the whole. So that's the superpower. I don't want to explain too much just so I don't bore you and I don't take too much time. But the whole idea is that you can have the largest JSON file that contains 1,000 fields, but at the end of the day, you just have one single hash, one single value that represents it, right? And you can store that hash now would represent the signature of that request. So if you go back to the body, no, let's just keep that. So what that would look like is, let's say you have a JSON body or a JSON that looks like this. You would ignore, maybe for the beginning, you would ignore the values, and then you would focus on just the keys. So these are flattened keys. I take the deeply nested JSON, flatten them into like a list of these kind of keys. And then I can hash each key, and then hash at each level, hash them, and eventually it becomes a tree of hashes. that represents that signature. That means if you have an endpoint that maybe sometimes it returns a user's account details, other times that endpoint returns the user's address details. Those two details would have different hashes and two different signatures. So with a Merkle tree, what you're able to find out is when a new hash appears, you know that there's a change, there's a new signature. Maybe a field was added, maybe a field was removed, right? And then that already removes half of the work. You don't need to go to the LLM for every single change. You can now go to the LLM only when a change happens and you think that change is significant. So I'm just going to be a bit quick. So the main benefit, like I said, is to detect that something has changed. And then the second benefit is that when you know something has changed, you can walk the tree to find the new hash within the maker proof. And that hash can point to exactly where the change is coming from. The third change, the third benefit is, let's not talk about it just for a lack of time. And then the most important benefit is that these hashes take 20 nanoseconds, which means you can have the largest JSON and it will be like just a few nanoseconds to compute it into a signature that represents all of this. Now, we've looked at how to find that there's new changes or whatever. But what about the logs or the huge messages? I also don't want to spend too much time just because lack of time. But it's possible if you have a lot of values that usually look the same, for example logs or whatever, to compute it. So each of this is one line, and you can compute it into something that looks like this. So it's sort of templates, right? And we do this using LLMs actually. So you ask the LLM you give it an example, we call it a few shot example, and tell it to generate, basically to just put placeholders in where it thinks the placeholders are, and then post-process it into something that looks like this. Then the next step is you now tell the LLM, take this message and give me this template, but as a regex. So that means that for every new log that comes, you can just take that regex and apply to it and convert that message or that log into a signature that is unique. It's not too specific, but it's now unique to the class of log messages. That means, just like with the maker proofs, anytime a new kind of log appears, you will know because you don't have that template, right? Okay, let's just speed through this for a little bit. And I actually use small large language models. When we started, we're trying to do a lot of these embeddings, these very smart things, trying to build custom models to catch and create these templates of the messages. But karma is not karma, but like reality is a bit so I don't know if I can use curse words here. But it turns out that the default models are actually smarter than any embedding you would do for these kind of things. So you put in a lot of work to create this special embedding that can catch all these anomalies, and then an off-the-shelf Quen 8B actually ends up better. So a lot of the academic papers just basically discovered this, that it was better to just use the off-the-shelf models. And the small language models, the small models that can fit in your laptop, they end up being the best for this, which is good because they are fast and then they are free since you can run them. They're open source. You can run them on your own hardware. Yeah. And this chart here shows this is like a coefficient to show how good the templates that we created is, right? The open source models, they're just so good. And the small model actually performed better than the 70B huge Llama 3 model. So it performed slightly bit better than this. Crazy, no? And then GPT 3.5, the old one, actually performed better than all of them. Yeah, so let's just skip this for time. Yeah. So the workflow now that we know you can use micro proofs to catch that there's a new change, and we can use LLMs to, I don't know, create value templates. We now had a workflow where we just create the maker proof, take all those changes that we've detected to an LLM and ask the LLM, is this an important change? Is this critical? So what that looks like, I'm just going to speed run this through a little bit. But what that looked like was that we now know that there's a change. Something has broken, something is new, and we can now ask an LLM to give the details and to tell us, is this a severe change? Is this critical? How important is this? And in our products now, what that meant is that you could get this kind of alerts that tell you, oh, on this particular endpoint, these are the new fields that this maybe some third-party API that you depended on. This is what they introduced. I think it's a bit difficult to read, but we can see exactly how it used to look like before, how it looks like now, and you get this change log of every API calls you make, what has changed, and how does it look. Okay, I think I've almost run out of time. This ability, goes beyond just APIs. So we also use it for things like errors to group and find patterns within the errors, so that when a new error or a new exception appears in our systems, we know that something new and noteworthy has appeared. So I think I'm gonna just stop here for today. Just come say hi at our booth. We have a booth downstairs. I can show you, what I know, in better detail than what I can do in a very short talk, and show you what this looks like. And again, please give us a star on GitHub. You can also read the code; it's all open source. And yeah, thanks everyone.